Welcome to another Blender procedural tutorial. This time we're going to be looking at Sverchok, and we're going to be having a look at this BenQ ScreenBar Plus lamp. It's a desk light that doesn't take up any desk space, and just finding a way to model it with Sverchok gives us a whole load of control to use it parametrically and to create some variation in the design as well. So if you're a designer looking at Blender as a potential for doing product or architecture, something like that, Sverchok gives you a good base. The model here has the same functionality that the actual light has. So I can change the temperature from a blue light, daylight, all the way through to a warm light. And I can also change the strength from bright to dim. And as well, we can rotate the light and you can see that it's shifting bar of light. Ergonomics is something that I've been getting more interested in and more kind of aware of since summer. So BenQ were kind enough to send me the ScreenBar Plus, and this is a monitor light. So it just hangs on the top of your monitor. It provides this region of light that considerably reduces the contrast where I work. To my eyes, there's not so much contrast in between the monitors and the environment, whereas a camera shows you with a flat exposure what is actually going on. So thanks to BenQ, let's jump into Sverchok. So I see from the YouTube analytics that at least 35% of you are not watching on a computer. I've increased my window scaling quite a lot. Let me know if this helps. I feel like if it's more readable, it'll be more followable. Best thing to do when you open Sverchok, press N, go to your Sverchok tab, General Utils, and then just click check for updates. I've already done this just about 10 minutes ago, so currently no commits for me to download, but if there were, then you can just upgrade the add-on and restart Blender. My UI layout is very similar to how I set up for procedural texturing. So I have a 3D viewport, and instead of my UV editor, what I have here is a text editor and the timeline. The text editor is really useful for being able to view the output from certain nodes as text. Working with nodes, obviously with Sverchok, so big node editor. And I've just got my outliner and properties panel. Make a new tree, rename this to ScreenBar Plus. The first part that we're going to be working on is the bar of the lamp itself, which is more or less cylindrical, but it has kind of a V cut inside it. The way that we are going to be generating this is as an extrusion. Add a number range. We need our number range so that we have a number of stops, right? So if we then put this through a scalar math, set this to sine and cos, this gives us both as outputs. And then if I was to plug this into a vector in, and we're going to go cos into x, and sine is going to go into Z, because we want this to be upright as a circle. I'm going to Control Shift click on there, and you can see that we've got our points starting to appear. If I change my number range to count, then we have a certain number of nodes, and we can now set the start and stop points. I'm going to just set mine slightly below the center, more or less horizontal. This doesn't matter too much. It's just basically to give me most of a circle and then a flat section. What I want to do is I want to take these vertices and I'm going to connect them to a modifier make UV connection. This is the way that we can create edges very easily. So if I Control Shift click on that, I'm making polys. So I'll plug the data output into polygons. You can see straight away that this has generated a face within this space. I next want to add this kind of V cut that comes up inside here. So if I just click this auto generate, then we're going to add a new one. And you see that we have this error here saying list index out of range. This is going to require us to do something. This is to do with the way that the information from here, if I add a viewer text node, and I just always set this to auto update, we jump into our Sverchok viewer. You see that we've got our points here and they're all in a single list. And what I would like to do is I would like to split them into individual items. So one object per item. What I need to do is I'm just going to bring this forwards, and I'm going to grab a list flip is under list structure. And if I just drop this on here, and we're going to flip at level 1. Now you can see if I plug this in to the viewer node, you can see that we have now 10 objects instead of 1, and each object contains 1 object instead of 10. We now just need to make sure that we are going in the V direction. This allows us to go up through the tree, so object by object, rather than list item within an object. So if you consider a list of 10 items within one object, like we had before, going in between these within a single object of a list, this is like the U direction. And then each object is kind of stacked on top of each other. So that's like our V direction. So that's why when we flip it, we need to be using the V direction, and we don't in this case need to use caps or cycles or anything. We're just making poly, and we want to make a slice. Great. So this is our profile, we want to be able to basically move this around. This is one of our parameters now of our lamp. So I'm just going to pull this over here, something like that, just so that we've got that internal corner. The next thing I need to do is scale this, because at the moment we have a meter radius, which is huge. This lamp has a radius of around about 1 centimeter. So it's currently 100 times too big. So we're going to go vector math. And just the same as with the vector math in shaders, we're going to go for scale. And that is the multiply scalar. I'm just going to make a separate value node here, and this is going to be our radius value. And if I just change this to 0.01, then we have the proper profile. I do sometimes find with Sverchok, because I don't always use mesh viewers, I often use these temporal viewers. The zooming in Blender, you know, when you kind of run out of zoom steps, I find it's quite convenient to just take something like an empty, scale it down to the right size, and now I can use the number pad period, and that's going to allow me to zoom in there. Now we have our radius control. We want to actually extrude this. So I'm going to use solidify. So if I just go in here, solidify, that is here. You can either search for it or it will be under your modifiers make, and then solidify. Drop that on here, make sure that you're plugging into the vertex input there. And we're going to take the polygon list, which is coming from our UV connection. This goes into polygons. We're going to plug our polygons into our temporal viewer so that we can see that there. This now has depth control. So let's just add another one of these values, and I'm going to call this one lamp depth. And the actual length of this lamp is 45 centimeters, so 0.45. And let's just plug that into the thickness. I'm going to want to move my lamp as well, because I want this to all come out from the center. I want this whole system to be symmetrical. So I'm going to also add a transform move node. Drop this on here, vertices. This is just a movement in the vertices. And the way the move node works is you set your axis that you're moving in, and then the strength is essentially the distance. So we will be moving in the y-axis here. So as my lamp depth increases, I need to be moving back in the negative direction, but by 50%. So if we add a number, scalar math, plug our lamp depth into the math here, I'm going to just divide by 2, plug that into my strength. And I want to make this minus, actually, because it needs to go in the negative direction. So now you can see that as I move this, we have equal and opposite stretching. So another part of this lamp is that it can rotate, and it rotates around its axis within the bracket. Add a transform rotate node here, rotating in an axis, and that axis is the y-axis. Now you can see that we have control over this, and we're working in degrees here. Let's just add a value node for the rotation. So that rotation needs to plug into the angle of the rotate node. So let's just group our controls here. Control J, rename this controls. And I'm just going to group everything and rename this lamp. Next thing I want to do is add the end caps. For our use, we just need to be able to isolate the end without this vertex. And for us to do this, we're basically just going to grab specific vertices. So let's grab an index viewer, visualization, viewer index plus. And what this does is it lets us look at the indices of the actual vertices. So let's plug this in. So we have 0 to 10 on one end, and then we have 11 to, it will be 21 on the other end. We need to be able to split this so that we have the two ends separated. We're going to get a list structure, list split. And you can see that by default, we have a split size of 1. And what this has done is it's made every item in this list its own object. So you can see that if I increase the split size, now we have 2 in these and 3 in these and so on. What we need is we need half of them in each side. So one way that we can do this is we can right click to bring up the Sverchok menu and use list length, or that is also available in list main, list length is halfway down there. And we are taking this value. We need to divide this by 2. So number scalar math, divide by 2. And now we have got 11. If I plug this into my split size, now what we've got is 2 lists going 0 to 10. 2 objects, each size of 11. And this means that we have now sort of isolated each end. I would like to remove a specific item from this list. So we're going to grab another list node here. And we want list structure, list item, drop it on here like this. And you can see that as we move through here with the indices, we're selecting a different vertex each time. I need to be selecting number 10 because I can then use the other socket to produce everything else, right? So I can produce everything except from number 10. 10 is not consistent right? So if I go back here and I change this value in here, say I wanted to make this much smoother surface or even much lower, you can see we've changed the shape there, and we no longer have number 10 being the final one. The number is the number that is in this count. So we need another controller here because we need to pull this out. Rename this to be resolution. So we can think of this resolution as the resolution of the curve, right? So if I go and connect the resolution value, which incidentally is going to be an integer, and if I just set this to 5, connect that into the count of your initial number range, that has now set us having five vertices there. And if I then also connect it up to the index of our list item node, now you can see that our index from the index viewer has disappeared on that final item. If we change this, then you can see that we are always taking everything except from that final item, which is exactly what we need. So I'm going to add another UV connection to make my actual face. So I'm just going to search UV connection. Then I can connect other. This is important. This other not item. This goes into my vertices. And if I Control Shift click on here, we're making polygons. So data goes to polys. And you can see, if I just turn off my indices, that we now have 2 end caps. So you might think, why not do this earlier? Because we made this shape before. But the point of this is that we now have an end cap, which is in the exact right position for the end of our object, because we're taking that end face each time, even if it's a different size or a different resolution, it's always going to be the same face. So it's going to match up perfectly. And also any rotation that we have is going to hold true because we're keeping all of the attributes of the actual lamp body for these end caps. What I need to do is I need to solidify again. I'm just going to connect this from our UV connection. Now, the issue is both of our ends are scaling in the same direction there. The solidify is going in the same direction, and we can't have an end cap going into the middle here because that's where the body of the lamp is. So I need to take the left-hand cap here and I need to flip the normals. It's actually quite easy to do. So I need to first of all get a flip normal node, and let's plug the data into the polygons into our solidify. So you can see that if I click reverse, it's reversing both of them. And what we need to do is we need to mask, so add the mask flag there instead of match. We now need to plug something into the mask socket that has a 0 and a 1. So yes for this face, no for this face. There's only 2 faces that we are needing to consider. So if I go number list input, this is going to let us write a manual list. Plug that into here. We need a list length of 2, and we need them both to go outwards. So great. Now we've got 2 end caps that go in opposite directions. Thickness of these end caps is around about 2 millimeters, 3 millimeters. So 0.003. That's going to give us the end cap thickness. And you can see that that is looking good. So end caps are done. Let's just group this section. Control J to group it and rename it end caps. So we don't actually want any special controls for this. The end caps are passive. So in theory, they should now follow our lamp radius, which they do, our lamp depth, and our lamp rotation. Great news. So this is one of the really good things about parametric systems is you can build all of this in and then you can go and change something which is really fundamental to the design. But all of those changes, if your node tree is properly connected, they're going to precipitate throughout. I'm going to use some mesh viewers now so that we can actually have a look at the mesh. So visualize mesh viewer. It's going to default to these default names. I'm just going to rename this so that I know in the outliner. So we've got lamp, and you can also set the collection. So I'm going to drop this into my default collection there. And I'm going to take rotate into vertices. You can see that we've generated the vertices now. And then polygons from the solidify. That solidify, they go into our faces. So now we have this object. And don't forget that this is still live, so we can still make all of our changes. It's now actually producing an actual mesh that we can find in our outliner. And we could even go into edit mode. It won't change anything. So, if I was to move something, but then change something in the tree, then it's going to recalculate the tree. So any edits that you make, they're not going to be considered in the tree. If you want to disconnect the tree from the object, you can either duplicate it, right? So it's no longer this one that I've just moved up here. This is no longer the live one, or you can just click live and it'll stop calculating that mesh. We also want to add the end caps, and we're just going to connect the solidify to the vertices and the faces to the polygons of that final solidify there, and rename end caps. Also, one of the nice things that you can do with the mesh viewer is that you can now use the modifier stack. I can add a modifier, a bevel, limit by angle. I'm just going to go quite high here, so 60, and we're going to go for 0.5 millimeter of bevel because this is very small, so 0.0005, and that will set that bevel. Now I want to have that modifier on the end caps as well, so Control L, modifiers, and that has connected with the same values. If you're in an older version and it's not bringing the same values, then you'll just need to copy those across or use the copy attributes add-on. You can just enable that, it comes with Blender. This is a lamp, so it makes sense that we add illumination to it, right? So we can have a number of controls that mimic the real light. So we want to have strength control, we want to have temperature control, and we also want the number of lights to be adaptive to the length. Rather than just saying there's 20 lights in here, we need it to be there's a light every 5 millimeters, give or take. We need to find the center point of this back face. For me to find the center line of this edge, I know that my list item is outputting the top of this back face, which is perfect. We want to have that, but we also want to have the bottom of the back face. We want all 4 vertices in a pair. So we want the left-hand end and the right-hand end. And what I need to do is take the other output. And if I just take the last value from here, then this will be the bottom of this face, regardless of the resolution. The last one on that list is always going to be the bottom of that face that we need. So list structure, list first and last. We're going to take other and we're going to take last. So now we have our 2 vertices, top and bottom. I'm going to use a vector lerp. This is a linear interpolation. So vector, we're going to be coming down here and selecting vector lerp. So I'm going to take my item into vertice A, and I'm going to take vertice B from this list first and last, the last output there. But now if I plug this in, you can see that as I change the factor, we are moving the specific vertex that we want in between. This is really useful because it means that we're going to be able to change the height of the LED strip, and we're going to be able to see how that actually affects the performance of the light. So from a kind of design review point of view, this is actually starting to become a useful model. I now need to just essentially draw a line segment in between them. To generate a line segment, I need a first and a last as separate sockets here. So what I'm going to use is a list decompose. If I grab my text viewer on the evaluation points and view this, you can see that we've got 2 objects containing 1 item each. So if I take a list main, list decompose, then we can come in here, take this data, have a look at it. So at the moment we're selecting both. If I go to level 2, then you can see that we're only selecting 1. Now if I auto set, then what it's going to do is it's going to generate enough sockets for all of the pieces of information that it needs to be outputting. In this case 2. If I plug this into my A and B of my line segment, and if I view this, now you can see that we've got a line along here. And if I change my interpolation, that line moves up and down. The number of cuts is going to generate vertices, and these are going to be the positions of the LEDs. If I have the length of my lamp, which I do here, now if I take a number scalar math and I plug this in, change this to divide, and we're going to divide it by the distance in between each vertex, which is around about 5 millimeters, 2 zeros and a 5. And then if I plug this into my segment, you now see that when we change the depth, okay, so what just happened there was I thought things were going a little bit strange. Things weren't really responding. I have turned on under Sverchok show errors. So I want to basically have verbose error reporting within the node tree. And we can see that line segment, this here says float object cannot be interpreted as an integer. And what this basically means is that we have a value coming out of this divide, which is in float. I don't want this to be in float. I want this to be an integer, which is the whole number of cuts. And to do this, we go number float to integer, and if I just drop this on here, you can see that we now have a control for our lamp depth, but all of our vertices here for the actual positions of the lamp. If I change this, then you can see that we are keeping more or less the same spacing. What I need to do is take off the first and last. So if we have a look at our indices, you can see that we've got indices all the way to the ends, and obviously an LED cannot be intersecting the end cap. So I'm going to take all but the first and last. So we go list structure, first and last, and we're just going to take the middle one, so omitting the first and final. We do not need the temporal viewer here because we're not actually dealing with a mesh. We're not generating a mesh. What we're generating is visualize lights. So we're taking the middle as our matrix. If you plug a vector into one of these blue sockets, the matrix socket, it's going to read that as the location. So if I plug that on there, then we're going to drop these into lights. And I'm just going to make sure that the size of these is small. You want something around about 3 millimeters. So 0.003 is fine. That's perfect for that. So right now all of our lamps are the right size, the right position, and also the right type. We're using point lights, but we don't have the color of the strength worked out. Let's just go into cycles here, just so that we can see what's going on. And first thing is that the strength is much too high. So if I go to 0.002, something really low, what I need to do is I need to color these lights alternately. So the way that the color temperature is working is it has two arrays of lights. It's got warm and a cool. And then it makes the warm ones more intense and it makes the cool ones less intense as you turn the temperature up, or I suppose the Kelvin down. Essentially, as you move to warm, it makes the warmer lights brighter. We can do this with Sverchok. We're going to set two colors. So if I go and search color in, and I'm just going to use just L here, and I want to look at what the color is doing. So I'm going to also add a viz texture viewer, plug this in RGBA, and let's turn up the luminosity here. So we want a cool light first. So I'm just going to bring this in towards the blue. So you can see that with this plugged in, we're getting that color of light. So I want it to be a kind of daylight blue light. Luminosity wants to be quite high for that, so something around there, 0.45, 1.9. Now what I'm going to do is I'm going to generate the warmer light, so 0.05, something like that. And we're going to go slightly darker as well, so more of a sort of peachy color. 0.65 seems fine for the luminosity. Really easy for us to make this flip in between them. We just need to join these two together into a list. So list main, list join, and we just connect them like this, just into the first and second data sockets. Don't need to touch any of the settings. What it's done is it's given us a list of first and the second, and then as we are iterating these lamps down the line, it's just repeating that list. So now you can see that we've got a warm, cool, warm, cool, warm, cool. So I'm just going to group these, Control J, color. That's just dealing with the actual color of the lights. And the next thing we're going to do is we're going to deal with the strength of the lights. Add a number mix inputs. You'll see these mixed numbers. We currently have a strength of 0.001, which seems quite low, but this is going to be our sort of minimum setting, 0.001, and our final setting is going to be 0.5. So if I was to just plug this directly into the strength here, now you can see that as I change the factor, we're dimming that light, and it's between two fixed points. This is just like using a mix RGB in the shader editor. I'm just adding a plane here just so that we can test it, and you can see that we now have control over the brightness. So the next thing I want to do is control the temperature of the light. Temperature switch is kind of more or less the same. So adding another one of these mix inputs, we just want this to be 0 to 1, and I also want to make an inverted version. So I want to take scalar math and subtract this from 1. So mix floats goes into the second socket of our math node, and then we're subtracting from 1. So this is giving us an inversion. This is because as we turn up the warm light, we want the cool lights to turn down and vice versa. So add a list main join. And we're just going to connect these two sockets here with the inverted version and the normal version. After that, just multiply by our strength, because at the moment this is just 0 and 1. Multiply by the strength, and that gives us the proper brightness, the strength of the light. And now if I bring back that plane, you can see that as we turn up the factor, we go to a blue light, and as we turn it down, we go to a red light. And I'm just going to group all of these together just to keep everything neat. Control J, LEDs. There we go, nice. When we've moved things, so if I right click shade smooth, and then if I change the resolution on here, it goes back to being flat shading. On the actual mesh viewer, if you press N, go to your item section, then you want a smooth shade from the mesh viewer. And we'll just go across to the end caps as well. Select this mesh viewer, smooth shade. There's another part of this lamp, and that is the bracket. The bracket is a little bit more complex, but we're going to be doing it with some more interesting nodes as well. So I'm going to show you a full range of workflow here, and part of it's going to be a little bit of scripting using the profile parametric node, which you basically use SVG syntax, I suppose, to generate your mesh. It's actually really simple to use, but it took me a few hours to get my head around it, so I'll show you that. The first part of the bracket that we're going to generate is the actual clamp that sits around the main body of the lamp. We want to take the lamp here. This is the overall shape of it, centered. This is important. It's centered at the moment. I'm just going to take this part here, and we can, because we've got our radius pulled off anyway, we can always rescale later. This doesn't get rotated at all, so it's another reason that we're not taking it further down. We're taking it right early on when we're generating this, but we do want it to have the same number, like the same resolution of the curve. So we've got our full section here. I want to omit these first and last. We're going to grab a list structure, list first to last, and we're just using the middle ones, so level 2. And now I want to add a vector math multiply scalar. So this is going to let us come down to our radius. So let's plug this in. So now we've got small, and as you can see, it's not rotated. So we can rotate the light and the bracket will stay fixed. The next thing we want to do is create another loop outside. So I'm going to take another one of these, Control-Shift-D, and I'm going to make it slightly larger radius. So number, scalar math, and we're just going to drop this onto the noodle from the radius. And we're going to add the bracket thickness at this point. Just put this on a separate controller. So the clip thickness is going to be more or less the same as the end. So about 3 millimeters, 2 millimeters, so 0.003. And we are adding instead of multiplying. So we're making this clip bigger. So now what I can do is I can grab the modifier make UV connections. Just connect both of these up to our UV connection node, and we're going to plug this in up here like this. Now you want to make sure that you have got it set correctly. So our direction is U. We do not need cycle, don't need cap. We're making polygons instead of edges, and we do not need slice on. You can see that we've got mesh inside. Slice is going to make the small loop and also the big loop as separate. What we need is for these to be connected. So you can see now nothing inside, and we've got these connections going on here. I'm just going to increase the resolution here because at the moment this actually wouldn't hold. So for now we're going to work entirely on profile, and then we're going to extrude it back just how we did with the lamp. So staying in side view here, what I want to do is create my profile parametric. And the shape of this is kind of down and then along. So this is the first one. It has a little overhang at the front as a clip, and then it comes back up here. And then we also have a second piece, and it's going to come down like this, have a circle at the end, and come back up. Apologies for the drawing. So I'm going to be using 2 parametric profiles, and we need a certain amount of information actually from the tree to go into those profiles. For example, we need to know where we're connecting and where these things exist. Add a generator, generators extended, Profile Parametric Mk3. I'm going to make a new file here. So hover over my text editor. If you press Alt-N, it's going to generate a new text. And I'm going to rename this one BracketTop, because this is the first section of the bracket. Now my profile parametric, I'm going to select that text. First thing I need is a start and finish position. And the start position is going to be the left-hand most vertex, this one here, which is just sticking out here. I need to isolate that specific one. So if I am looking here at my larger circle, this multiply scalar node, I need to take the vertices on here and I need to find the one which is furthest on the left. And this may not be the quickest way, but it is quite a thorough way. And it lets you have quite a lot of manual control if you need. So I'm going to take a vector out. This lets me split the vector, separate X, Y, Z. And then I'm going to do a list sort as well. So a list structure, list sort. And we're going to be sorting the vertices. Grab a text viewer Mk3. You can see that we've got 15 vertices in here, and we want to sort them by the X value. So what I'm doing is I'm taking the X value and I'm plugging this in as my key. First of all, nothing's worked, but this is just because we're in level 1, and this information is actually stored at level 2. So if I go in here, change this to level 2, you can now see that this is working. And then I can take the first item from this list. So again, we're going to go list, structure, first and last. Then if we take the first one, then you can see that this is the one which is on the left-hand side that we want. Separate to that, I'm taking the last one from the multiply scalar, and this is all of the vertices, the final one, which is at the bottom of that row. Control H on both of these, just so that I've got the specific sockets. And then we can only input scalar values into the profile parametric. We can't input vectors. So I need to now separate these. And I'm just going to plug this onto both of these like so. Let's jump back into our BracketTop section. The way that this syntax works, right, is you set your first position, which I'm going to use M, capital M. Well, let's just do a little test actually. Let's just draw a couple of lines. So we're using M to declare the start, and then we are using a lowercase l. So uppercase means you've defined an explicit location, and lowercase means that you're defining a relative position. So if I was to go 0.1, comma 0, and then if I press Control Enter, and so now you can see that we have drawn from 0.00, which is so capital M, absolute, we've defined an explicit location, and then we have gone in that direction. And now if I put a space and I put in the next one, so let's say I want to go nowhere in the X, but in the positive Y by 0.1, Control Enter over the text editor, that's going to force the update. Now you can see that we have drawn up. Now let's say you want to close this shape. I'm just going to put a lowercase x, and that is going to close. It doesn't matter if you put space or enter, as long as it is after a letter. I'm just going to go down here, 0.1, 0.2. So if I do this, let's get rid of that x. You can see that we've now gone all the way up here, but it's relative because it's following this lowercase l. If I put an uppercase L here, then you can see that we've actually just defined the specific point that we're going to go to. And if I do that, then you can see that we've moved the previous things out. Parametric profile lets you define parametrically the entire shape you're going for. The next thing that is worth noting, if I put in A or any string, right? So let's actually just write test just to show that. And then we're also going to go 0. So now if I press Control Enter, you can see that our error logging is saying no data passed into socket test, and it is generated a socket with the correct name. So if I was to add a number in here, now see that I'm able to control this from outside the node. If we want to be able to have it so there is no input, which we are going to do a couple times, you have to write default test equals, let's say 0.1, and then a semicolon. So now you can see that we have defaulted to a 0.1 move there. And if I plug something in, then it just overrides. This is the general syntax, the kind of the workflow that we're going to use here. The difference being that our M value is going to be startX, startZ, because we're going to be working in the Y-axis. So you need to change this on your parametric node because we're working front view. And I'm just going to plug into our UV connection just with a spare temporal viewer, just so that I've got that visualized. So startX, startZ, and this is going to just say there's nothing plugged in. No data passed into socket, startX, and startX is here, the left-handmost vector. So startX, now it's saying startZ. We're going to just draw a line to the finish point. We're going to draw a line, capital L here, because we're going to the absolute location of endX, endZ. And we're going to get the error, you're not passing anything through. So we just need to connect this and this. See that we've now drawn a line in between those two. If I change the resolution, then you can see that this moves and it updates correctly. And when we get to a certain point, there's a new further left node. I'm just going to set this to like 32, just so that we've got a view being skipped there. And now let's do some things. I want my bracket to move relative to the radius. We're going to go left by the radius, and we're going to go down by half the radius in between these two. Lowercase l, because we're going relative now, we're moving from one point away from it by a certain amount. So we're going to go in the x by minus radius. This is going to prompt us to generate a socket. And we're going to go down by minus radius as well. Control Enter, generated a radius socket. Let's go and grab our radius. I'm just going to join that up to the radius socket. Great. So I only actually want to go down half the height of the radius. So times 0.5. It looks like the syntax should be correct, but it's not doing anything. And if I refresh this on the node, you can see how much of it is passed, and then it'll say leftover. So this is the part that is failed on, and it's failed at the asterisk. And what you need is you need curly brackets. Curly brackets contain maths for you. The next part we need to do is going to move along by a certain distance, which we're going to call top length. So we're going to go minus top length, and we're not going up and down at all, we're going horizontal. No data passed into socket top length. Let's add ourselves a default. Default top length equals 0.05. So now you can see that we have gone further back there. We still have a socket that we can plug into, but just for now, we're going to be working with defaults. Just going to do this on a new line. I'm going to draw a line. I'll come back to it and make it into an arc later. So we're going to go horizontally by 0, and we're going to go down by the bracket thickness. So bracket thickness, and no data passed in. So let's make a new one. Make sure you're finishing your default with a semicolon before you start another default. And our default thickness is going to be 0.01. Make sure that you are using negative down here. And then we're going to work our way back. So this down will actually be an arc. I want to get my straight lines out of the way first. So I'm just going to put another L here. We're going to be going to the right by the top length, and we're not moving up and down. We actually need to be moving slightly shorter than the top length. So the top length minus 0.002. It's not done anything. So just make sure that you have it in curly brackets. Let's join that up. And then we're just doing this little clip, right? This is a top mounted monitor lamp. So it's got this little hook that hooks around the front of the monitor. So we just need to come down by 0.01, forwards by 0.002, 0 in the Y, and then we're going to go back up. So 0 in the X, 0.01 in the Y, making sure that my first one, make sure that's a negative. And this has generated our little hook. Arcs are what took me a really long time while trying to work out how to use this node. We're doing lowercase because it's relative. So this is for an elliptical arc. Ellipses have 2 radii. So you have to define your radii. So radii 1, radii 2. And then we use 3 flags. One, I think, does nothing. And then the next 2 choose which part of which arc you use. And then the final section is your finish position. So these coordinates that we've already written, these are our finish position. I'm going to be generating a radius. So I'm going to put in a new bit of syntax here. Essentially lets us create a sort of alias for a string. So I'm going to say brac. This is going to be half bracket thickness. So brac equals curly bracket because we're doing a bit of math. And in here, I'm going to type in bracket thickness times 0.5. So in the start of my arc, I can go brac because we're doing a circle. So both of our radii need to be the same. And then just to begin with, I'm going to put in 3 zeros. So 0 space 0 space 0. Now if I press enter, you can see that we've generated a semicircle. These 2 flags, these last 2 flags, these control which part of which circle or ellipse that we're working in. So basically, I just want to change the second arc flag here, the sweep arc, because instead of going inwards, I want to go outwards. So change this to a 1, press enter. You can see that is now reversed, that section. Excellent. This is all of the code that we need for the first part. If you wanted to close it, you could finish with a lowercase x, and that's just put that on there. Just for completeness, I'm going to search fill hole, and I'm going to drop this on here, and you can see it's not done anything. This is because it's saying 4 sides. We actually want this to be much higher. We could always use a list length, and basically take the length of this into here, and that's always going to be correct, regardless of how you change in here. Or you could just, because we're leaving this now, we now could have just put in a constant. So this is the top part of the bracket. We are now going to make the second part of the bracket. So I'm going to duplicate the profile parametric. We're going to make a new part. Over your text viewer, Alt-N to create a new one. And now we are going to call this one bracket foot. So this is the part that actually hangs over the back and counterweights. Make sure you select bracket foot in your profile parametric. It says invalid syntax at the moment. This is just because we don't have any syntax in here. So let's just type M00. Make sure that we are working the y-axis as well on your node. We do need a certain amount of information. We need our startX and startY because we essentially need to retrace our steps to this point. I'm going to use another let command in here. So let footx equal curly brackets. And then we just need to say startX minus radius minus top length. I can also let my default top length equal the same, which was 5 centimeters. So equals 0.05 and a colon. Something about this node, you cannot reorder your sockets. So they just get generated in the order that you make them, which is not always the neatest order. But I'm just going to connect these things in. So startX has been connected. This is our radius. And right now we're not outputting anything at the moment. We just have the center at 0, 0. This is how we get back to start position. We then want foot Z as well. So let foot Z equal startZ, because we're going to start in that position. We need to come down by radius multiplied by 0.5, close brackets. So I'm just using brackets just to make sure that I'm doing things in the correct order here. So radius times 0.5, and then that's it. We've got our foot X and foot Z. This is going to be our new positions here. So foot X, comma, foot Z. No data passed into socket Z, so pass that through. Now I'm just going to draw a line. This is more of a kind of flag just to make sure that we're in the right place, which is on this corner. I need to draw an arc first. I need to come down by the bracket thickness, so minus bracket thickness, and it's going to say no data passed into bracket thickness. Our default bracket thickness is 0.01, so 1 centimeter thick. And then we want to come along. I'm just going to do this on a new line. Just that first one is a placeholder for an arc. So we're now working on the actual straight line. So we're going to go to the left by 4 centimeters, but we're actually going to call it foot length, right? So foot length, and we're not going up or down, we're doing this horizontally. And I'm going to just set a default for foot length. Default foot length, come in like that. We actually need to go negative because we're going to the left. We then need another arc. So again, just a placeholder, not anywhere in the X, and we will be finishing bracket thickness above. And then I'm going to close this. So X finishes the line. So let's work a couple of things out. We have to do the first arc. Let's define our bracket thickness times 0.5. So let brac equal curly bracket thickness times 0.5. And this is important because this is the radius of our first arc, right? So I'm going to change this first L to an A, lowercase a. And I'm going to go brac 0, 0, 0. See where the leftover is. Okay, so it's saying leftover is when we get to this bracket line, and this is because I used a space instead of a comma. At the moment we're going to the right, I want to flip this, so I'm just going to take that second arc flag and rename that to 1. So now we've got that negative curve, and this gives us essentially a receiving curve for that one on the first section. The second part, so this is another A, we're going to be making a much bigger one. So I'm just going to go 0.02, 0.02, 0, 0, 0. So you can see now that we have a much bigger curve, but it's just a little bit of it. So we're taking essentially the right hand one. If I was to change this to 1, and you can see that we flipped it. If I was to change this to 1 at the beginning, then you can see that I've got the right hand large arc, and we want the left hand one, so change that at the end. Now the 0.2, 0.2, I want this to be an input. This is the foot radius, right? So make a default. Foot radius equals 0.02 semicolon, and we're just going to call this one again here. So foot radius, and I want to connect a few value nodes. It's all well and good having the defaults, but actually the great thing about procedural systems is all the customization, variability. So a number, call this one top length, and our default was 0.05. And we need to make sure that we plug this into both, and that comes with now. We also want to have bracket thickness in both. This should be 0.01. And we also want to have the foot radius as a controller, and foot length actually, sorry. So foot length and also foot radius. Control J on these, I'm just going to pull them up. The node tree in the comments below is going to be much more organized. I'm going to sort out all of the reroutes and things. This is how we use the parametric profile. It's a super useful node actually, just because it's so versatile, being able to actually like explicitly say this is where I want this line to go. And you can use maths in it, and obviously if you want multiples, you can put like a range, a number range in there. Edges goes into here, vertices goes into here. Take another temporal viewer. There we go. So now we've got 2 sections of this lamp. I'm actually going to just stick a rotate on here beforehand. Transforms rotate, and you can see that this at the moment is rotating in the Z axis, which is not what we want at all. So I need my axis to be Y. But at the moment it's also rotating around 0, 0. So how do we generate the center? Because this center needs to be dynamic. It needs to move depending on the center here. We could just do this with maths, right? We could just retrace our steps. So it's just the same as your foot X, foot Z, but half a bracket thickness down. So you could just use math nodes. We're actually going to use a formula node. So if I just type in formula, this formula node is great. If you like just typing in a bit of maths and you know what the maths is that you're needing, super useful. And again, it's going to take your strings as the socket name. So startX, which is the position up here. So you can see immediately that's given us a startX socket. And then we're going to use minus the radius. So now we've got a radius socket as well. And then we're going to minus top length. That's actually it for the X. Let's connect these up. We've got startX, we've got radius, and we've got top length up here, one of our controllers. So that's basically why we needed it to not be a default. We need it outside because we need to access it here. I also need a formula for the Z. So I'm just going to duplicate this down. We want to take our startZ. We would then like to subtract half the radius. So radius in brackets times 0.5. And then we also want to subtract half the bracket thickness because we're trying to get to the axle position in the center of the bracket. So open brackets, bracket thickness times 0.5. Then we can take the startZ in here. The radius again we need to take in, and the bracket thickness. Make sure that you name your nodes correctly because I actually connected the wrong one to my first formula there. Bracket thickness can be joined up to my second formula. So now both of these formulas are outputting a value. You can see on my stethoscope there that we are outputting around about 1 centimeter, half a centimeter, something like that. So it's within the ballpark of what I would expect. And then vector in, and then we can take the X and the Z off there. Now this becomes our new center. So now you can see that as we rotate this, yes, it does clip through, but it also rotates around the correct point and it gives kind of the correct impression of what we're trying to do here. So we've used the fill holes to generate all of the faces on here, and we have our initial sort of wrap around the top, around the lamp, top section of the clip, and the back section of the clip. So let me just pull this out here just so we've got everything more or less in the same place. We need to just join these three together. So list main list join. This is going to be our vertices. So I'm going to connect the first one, the second one. These are of our parametric profiles, the actual bracket. And then the clip comes from our UV connection that we made before. So that goes in here as well. Don't need to change any of these settings. This is all fine. So you can see that we've got all of our vertices now showing. We just need to join up the polygons. So I'm going to take the polygons in the same order from each one of these. So the two fill holes and then the data from the UV connection. See that when I join this into here, into polygons, now we have all of those edges. I'm going to throw on a solidify now. So search for solidify, jump it on there, make sure vertices is going the right one. Polygons connecting to polygons. Now you can see that we've actually got a 3D one, and it looks like we're going to flip the normals on one of these. So as this increases, let's give ourselves another number. We're going to be calling this one the bracket depth. So this is the Y dimension. Looking at the bracket here, it's around about 0.05, 5 centimeters. And just how we did before, we're also going to then move, to transform move. Axis is the Y axis, and the motion is going to be the thickness that we are solidifying by, halved. So we're centering it. So scalar math, divide by 2. So now you can see that as this increases, we are still centered here. You may have to do -2 depending on your normals. I have 2 going in the same direction and 1 going in the other direction. So it's easier for me to just flip 1, which in this case is our bottom parametric, add a flip normals, and I'm just going to drop this on here, making sure that I have my polygons coming through like this, and then I can reverse that 1. So there we go. That's going to give us the actual clip shape, and I'm also going to put this onto a mesh viewer. Add a viz mesh viewer. I'm going to rename this one to bracket. If I plug the vertices here from my move into the vertices of my mesh viewer, and then the polygons from my solidify into the faces, and you can see that we've already got something pretty cool coming out. I'm also going to just select these 3, select my original lamp, Control L modifiers. This is looking good. Now we've got basically the full system in place. So a couple of added bonuses that we've got here. We want to have some control from within the 3D viewport, and this is quite simple to do. What you can do with certain nodes, the main one that we're going to be using here is just value nodes, regular value nodes. We come over to our controls. Let's say that I want my lamp rotation to be controllable from within the 3D viewport. What I can do is I can select my lamp rotation value, come into the properties, and this tag under the item to 3D view, if we click this, under the tools, we have got lamp rotation in the 3D viewport. That's pretty cool. I can now rotate this without ever actually visiting the original Sverchok tree. Another one that we may want is the length, so lamp depth. The name of it is going to come from the name of the node. So just make sure that you name things correctly. I'm also going to add the strength and temperature control. So I need numbers for both of these. I'm just going to set a minimum and maximum as well, because we're just doing factors. Now, if I connect these to the 3D view, then you can see that we've got these as values that we can control inside the 3D viewport. So you can see that we've got ourselves a lamp where we can control the length of it procedurally, parametrically. We have all of these controls. We can rotate it. So this is actually how the lamp is adjusted in real life. You just rotate it in this bracket. Something kind of interesting that we can just have a quick look at. Where we position the lights with the vector lerp, this has quite a big sway over the quality of the light coming out. So let's just turn down my strength just so that we can actually see the light bulbs. So you can see that if we move this up or down, then we get a different position of those lights. Let's just give this a control just so that we can play with it in the 3D viewport. LED position. Let's connect this up to our vector lerp factor and just make sure that we have this. So now you can see that we've got LED position in here as a control. So let's turn up the strength. The cool thing about these lights is they have actually a really concentrated kind of light. Not concentrated as in bright, but as in it doesn't go beyond where it's designed to. The LED position has a really big influence on that. So the lamp depth in real life, 0.45. The temperature is variable, the strength is variable, and the rotation can be varied as well. So you can see the effect of rotating it there. I know this node tree might look like there's a lot of noodles going around. I will clean it up. There is quite a lot here, but that's just because of those parametric profiles. So in the description below, there's going to be a screenshot of this node tree, all cleaned up and annotated. And there's also going to be screenshots of the 2 parametric profile, the code. So that's the proper syntax, the full code as I've got it here. I'll just copy that in. If you would like to support me, you can do so on Patreon, where you'll be able to download this file in full. And yeah, if anybody else has products or anything that they would like to have kind of put through Sverchok, get in touch. So that's it. Thanks for watching. Thanks for sticking around, and I will catch you in the next one.